Hello everyone, I am Kartika of class 8 and she is my teammate Karamajita of class 8. We are from Doon Public School Panchkula Sec-21. We are participating in the CBSE Science Exhibition under Junior category.
Biggest challenge is of eating a healthy diet. Another challenge is storing the food. The food gets spoiled, but the refrigerators help us to store the vegetables and fruits for a longer period of time.
It's a bit noisy, isn't it?
Yes, it is, but there are a few more problems. It keeps on hiking up our electricity bills. And when the frost melts and the green leafy vegetables are kept close to the body of the fridge, they get spoiled easily.
For this, we have a unique idea of natural cooling and food refrigeration system. It is a sustainable solution to store excess produce. It uses the application of basic principles and technology, and it is also an indigenous design. It provides natural coolness to the stored material without requiring electricity in main chamber by using zero energy cooling chamber and decreasing temperature further using earthen and terracotta clay rectangular pot air coolers. Fruits and vegetables can be stored fresh without deteriorating their quality for 7 to 10 days, retaining their original taste, color and smell. The zero energy cooling chamber, originally developed in India, is a small chamber made out of bricks and sand where farmers can store freshly harvested produce before it is transported to the market. It works on evaporative cooling principle that can be used to provide a cool environment. Zero energy cool chambers stay 10 to 15 degrees Celsius cooler than the outside temperature and maintain about 90% relative humidity. Anta K. Roy and D.S. Kuridya developed a low-cost zero-energy cool chamber in 1991. It was an on-farm rural-oriented storage structure at IARI New Delhi.
Technology. A ZECC can reduce the temperature by 10 to 15 degrees Celsius, but it also keeps the humidity high. These are perfect conditions to store products. Mostly they are found in hot arid climate where access to electricity is sparse. Evaporation cooling process. During the evaporation cooling process, water is evaporated in the steam of the air and passes from a liquid to gas. The transition requires energy which is extracted from the air in form of heat. As the result of this process, air is cooled down. Thermal conductivity. Thermal conductivity refers to the ability of a given material to conduct or transfer heat.
Part of our project is ethylene gas absorber. We will place it in the inside chamber of our project. It is a colorless and flammable gas. The molecular formula of it is C2H4. It is a hydrocarbon gas with 4 hydrogen atoms bound to a pair of carbon atoms that are connected by a double bond. It is a small hydrocarbon natural gas and a naturally occurring plant hormone produced by plant cells that aid in the ripening and aging process of fresh products. Fruits such as apples, bananas and pears emit a greater amount of ethylene gas, which as a result affects their ripening process. If we are able to reduce the amount of ethylene gas emitted by these fruits, we can reduce their period of ripening process.
Conductivity?
Yes,
Which class?
it's of class 11.
But we are in class 8.
entirely made of terracotta clay. The dual wall chamber, it is also expected to be made of terracotta clay. The dual wall chamber serves as ZECC. The dual wall chamber, it is expected to provide unique support to all the vegetable sellers, economic class and all other classes who wish to save the nature and the ozone layer. The zero energy cooling chamber will be constructed in the different stages. Stage 1. In stage 1, the ground leveling will be done by using soil as the base. In stage 2, the construction of the basement and the floors will be done. In stage 3, an 80 centimeter long brick wall will be constructed. After that, the chamber's width will be 75 centimeter. There will be a gap between the two walls which is going to be 7.5 centimeter. This gap between the walls will be filled with a mixture of wooden powder, sand, river sand and charcoal in a proportionate 5 layers of various proportion of these items like river sand, cocoa peat, wooden powder and charcoal, so as to meet the parameters that are involved in making our model. PVC pipe of 2 inch in diameter will also be fitted in the side wall so that the water can easily pass through this mixture of sand and charcoal. Thus, this is the top view of our model, which is drawn on a graph paper in proper centimeter scale. For better understanding, the two side views of our model has also been drawn. One of the side of the chamber will also consist a PVC pipe of 7.5 diameter. It will be attached to the mitti cooler and to the inner chamber. So now I will be presenting you the 3D prototype of how a model is going to be. Our indigenous model will be fitted with a mitti cooler so as to enhance the decrease in the temperature. Our mitti cooler will be using the same technology as the desert coolers. That is, when unsaturated air comes in contact with the water evaporates. This will make the increase in the moisture level of the air and the temperature will drop down. So another positivity feature to our model is that we will be using vetiver root instead of straws. Why is that? Because vetiver root, they inhibit the growth of fungus and algae, which is a very good point for our model. Another feature of our model is that we will be using ethylene gas absorber. This gas is responsible for the rotting and the ripening of the fruit.
Thus, our indigenous unique mode have special features of portability, detachability of mitti cooler to use as natural cooling system and have enhanced techniques to decrease temperature in inner chamber. Naturally, to store fruits, vegetable for a longer period of time. Our model has many potential benefits like sustainable and low energy consumption, adaptability and built for small scale commercial application. Looking forward to present my model